Is this molecule aromatic, anti-aromatic, or just not aromatic at all? When trying to figure out if a molecule can be aromatic, we have a checklist of 4 things. The first thing in our checklist is the molecule cyclic? Number 2, is it conjugated? Are the electrons spread out throughout the entire molecule? That's what that means. Number 3, is it planar? Are all the atoms in the molecule sp2 hybridized? And number 4, does it follow Mr. Huckel's rule? And what is his rule? 4n plus 2 has to equal the number of electrons that contribute to our conjugated system. Now let's head on over to our molecule to see if it follows the checklist or if it just does not. We want to see if it's cyclic. If you can draw a continuous line throughout the molecule and come back to your starting point without picking up your pencil, then it's cyclic. We can check that off our list right there. Is it conjugated? That means are the electrons shared throughout the entire molecule? It looks conjugated. We have resonance here. This can resonate up to here. And then we can also resonate down here, resonate down here. Sulfur also has electrons that it can use to participate in resonance. Our system is conjugated. Now, is it planar? Are all the atoms in our molecule sp2 hybridized? Let's take a look. This is sp2, 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 sp3. Well, we're gonna have to take a closer look at this. Sulfur has electrons. It can use its electrons to resonate down there, which cause these electrons to resonate up there. And we can form the following resonance structure, where sulfur is positive, and then we're gonna have our negative charge here, and gonna still have our bonds here. Sulfur is now sp2 hybridized. Are we gonna consider all the atoms in our molecule to be sp2 hybridized? Yes, we are, because when an atom can contribute to aromaticity, meaning it's gonna use its electrons to participate in the conjugated system, it's going to use its electrons to participate. Because aromatic rings are extremely stable and the atoms want to jump in and be a part of that stability. That's why sulfur is going to be sp2 hybridized in this case. All of the atoms in a molecule are planar. Does it follow Mr. Huckel's rule? We just have to count all the electrons that are going to form pi bonds or that contribute to our resonance. And in this case, sulfur has a pair. That would be 2. And then we have a bond here. That would be 4. And then we have another bond here, which would be 6. We have 6 electrons in total that are contributing to our resonance. And so we'll just plug that in. 4n plus 2 is equal to 6 electrons. Isolate for n, minus 2, which is going to give us 4 is equal to 4n. And then divide by 4, n is equal to 1. And since we got an integer, it follows Huckel's rule, meaning we can check that off our list. We have check marks on all of these. And because we have check marks on all of those, that means this molecule is aromatic.